We're going to talk about combining functions. I think this is going to be a little bit more of an entertaining video as far as the math goes. It's not quite as dry as domain and range. Okay, because there's a little more algebra. And hopefully it'll be a little bit shorter. You won't have to sit through 26 minutes of this. All right, so let's check it out. When combining functions, right, we have given functions f of x and g of x. It could be really anything. It doesn't really matter. Okay, but we have a couple of things we can do to them, right? We can have a sum, which is when we add those functions together, we're going to take whatever those functions are and we're going to add them. We have the difference of functions. So we would have our functions and they're going to subtract. So we're going to have our first function and we're going to subtract our second function. How that will work, generally speaking, is we'll multiply all the terms in the second function by -1. Change all the signs. Okay, we could have a product function where we're multiplying our two functions together. So exactly that, we multiply. That would sometimes include things like FOIL and distribution. Okay, and finally we have quotient, which is dividing. And as you can see, we'd have a function divided by another function. However, we can never divide by 0, so we just have to make sure that we never have g of x equal to 0. Okay, that's the only restriction. We can't have it just a 0 function. Okay, but we're going to divide. And there's a lot that we can do with the fractions and division. We'll get into that a little bit more later. Okay, so let's take a look at how some of these functions work. Here, they give us three different functions. They give us f of x equal to 5x minus 8. They give us g of x equal to x squared plus 3x plus 9. And h of x, which is equal to negative 3x plus 1. Okay, and we're going to be doing each of these four problems. The first one calls for us to add f of x and h of x. So here's what's happening. We're taking this whole function of f of x, which is 5x minus 8. And we're adding to it this function h of x. Adding, which is negative 3x plus 1. So all we're doing here really is we're combining like terms. Right, we've got 5 and negative 3 x's, so when we combine those we get 2x for our variables, and we have for our constants negative 8 and positive 1, which comes out to negative 7. So when we combine f and h, we get 2x minus 7. Next problem says we're going to take f, which is 5x minus 8, and we're going to subtract g. G is x squared plus 3x plus 9. However, because this is subtraction, what we're going to do is distribute that negative to each of these terms. So we change the signs, right? X squared becomes negative, 3x becomes negative, and 9 becomes negative. So now when I combine like terms, I'm going to look at my highest power first. I have negative x squared will be my first term, and nothing combines with it because it's the only one. Then I have 5x and negative 3x. So 5 minus 3 would be 2x. And then I have negative 8 and negative 9. So when I combine those, we get negative 17. Problem C says f times h. So we have 5x minus 8 for f. We're multiplying negative 3x plus 1. We're going to have to do FOIL or distribution, however you want to say it. 5x times negative 3x is negative 15x squared. 5x times 1 is 5x. Negative 8 times negative 3x is positive 24x. And negative 8 times 1 is negative 8. That's FOIL. Okay, you can do it however you remember. It's fine with me. we get negative 15x squared. Combining our like terms here, we get plus 29x and minus 8 when we combine f and h. And last we have g divided by f. Well, g is going to be x squared plus 3x plus 9. We're dividing by f, which is 5x minus 8. Now, later on, we'll talk about factoring this and seeing if there's any like factors that we can cancel out. But for right now, just because we're learning the basics, we're going to call that a day. Would we want to talk about restrictions? Yes. We know that we can never plug in a 0 here, right? So we know that we can never have 5x minus 8 equal to 0. We're going to solve for x by adding 8. And then we're going to divide by 5. So we know for this particular problem that we can never have 8 over 5 plugged in. Okay, so that's the only thing we want to worry about if we have the fractions, is we know that we can never plug in certain values because we'll get a 0, and we can't have that. So we do want to list our restrictions. Okay, so you're going to see you have some U-try problems. So write these down, each of the functions. Go with it. Pause this video, see how you do, resume to check your answers. Alright, let's see how you did with these. We're going to do g plus h. So we've got for g 7x minus 12, and we're adding h, which is 9x plus 6. Combining like terms, we get 16x minus 6. For problem B, we're going to take f, which is 2x squared minus 5x minus 3, and we're going to subtract all of h, which is 9x plus 6. This has to distribute to both terms. So nothing combines with this 2x squared. We have negative 5 and now negative 9, which is negative 14x. And we have negative 3 and negative 6, which is negative 9. 2x squared minus 14x minus 9. Problem C, we have g times h. So we have 7x minus 12 times 9x plus 6. I suggest FOIL method. Right, 7 times 9 is 63. That's going to be our x squared term. 7 times 6 is 42x. Negative 12 times 9 is going to be minus 108x. Negative 12 times 6 is going to be negative 72. If we combine our like terms, right, the 63x squared is one of a kind. 42 and negative 108 is negative 66x. And minus 72. That's our final result for C. And problem D, we have f, which is 2x squared minus 5x minus 3, divided by g, which is 7x minus 12. That's the actual function. Again, we're not going to worry about simplifying just yet, but we do want to list the restrictions. 7x minus 12 can never be equal to 0. I'm going to add 12. So we can never have 7x equal to 12. Divide by 7. We know that x can never equal 12 divided by 7. All right. See, a little bit more fun types of problems, a little more algebra involved than the domain and range problems of last video. Right. We have another way of combining functions, which is called composite functions. Okay, a composite function is when you evaluate one function using another function. We would call this something like f of g, right? And we write that with this little circle, which means we're evaluating one at another. Okay, so when you see f of g of x, it means that we're taking the function g and we're plugging it in to f. How does that look? It looks something like this. Here we have f of x equaling 2x plus 6, and we have g of x, which is equal to x squared plus 1. So if we have this first function, f of g of x, f evaluated at g, that means that we're taking f, plugging in the function of g anywhere we see an x in that function. Okay, well, what does that mean? It means we're taking f and we're evaluating x squared plus 1 everywhere we see an x. Okay, well, how that happens, right? We're going to take the function f of x, which is 2 times something plus 6. What is that something that we're evaluating? We said x squared plus 1. And then we still have this plus 6 happening later on. Here we're going to have to distribute this too. So we have 2x squared plus 2. That's just from distribution. We still have this plus 6 from earlier. So when I evaluated f at g, when I finally combine all my like terms, what we come up with in the end would be 2x squared plus 8. This next one says g evaluated at f. Okay, well, that means I'm going to be taking g and plugging in x. I'm sorry, f, wherever I see an x. Or g evaluated at 2x plus 6. Okay, well, what is g's function? G is something squared. That something is going to be 2x plus 6. So we've got 2x plus 6 squared, and then we're adding 1 to it. Well, we might have to do this piece right here, the 2x plus 6 on the side. Let's just do that real quick. Oops. We've got 2x plus 6 times 2x plus 6. Let's see, 2x times 2x is 4x squared. 2x times 6 is 12x. 6 times 2x is another 12x. And 6 times 6 is 36. So we have, let's see, we have 4x squared. If I combine these, plus 24x plus 36. And then we have this plus 1 still hanging around from before. So when we combine our like terms, we get 4x squared plus 24x plus 37. Here we have a couple more examples to look at. At this point, if you'd like to try them on your own, you can, or you can just observe how these ones work if you're not quite getting the concept quite yet. Okay, so here we have two new f and g functions. We have f of x equal to square root of x minus 5, and we have g of x equal to 3x. Okay, well, if we evaluate f at g, that means we're taking the function of f and we're plugging in 3x wherever an x appears. Well, we know it's going to be the square root of 3x, and we still have this minus 5. That's not going to simplify any further, so that is f of g. This problem, we're going to take g and we're going to plug in the square root of x minus 5 everywhere we see an x. Well, g's function is 3 times that thing, which is, square root of x minus 5. So here we do have to do a little bit more work. We have to distribute the 3. So we're going to get 3 root x minus 15. We have one more problem for you to try on your own. Okay, so if you want to pause the video, do them out, and then resume to check your work. See how it goes. Alright, let's check these ones out. So we've got f of x is equal to x squared plus 7, and g of x is equal to 10x minus 2. So we're going to evaluate f at 10x minus 2. What that means is I have 10x minus 2 squared, and then we're going to add 7, because that's what the original function said to do. A little bit of side work needed. We've got to square 10x minus 2. So I'm going to do the FOIL method. We get 100x squared minus 20x minus another 20x plus 4. So that gave us 100x squared minus 40x plus 4. And then we're still adding that 7 to it. So our final answer will be 100x squared minus 40x plus 11. How did you do with f of g? Hopefully you got that one correct. Now we're going to evaluate g at f, which is x squared plus 7. So we're going to take g's function, which is 10 times something. That something is x squared plus 7. And then we're going to subtract 2. We have to distribute. So we have 10x squared plus 70 minus 2. When we combine our like terms, that gives us 10x squared plus 68. Well, that's it for that lesson. Okay, so combining functions is either adding them, subtracting them, multiplying, or dividing them, for now anyways. Okay, or we could composite, which would be evaluating one function at another. If you have any questions, leave them in the comments or bring them into class. We'll talk about them then.